So welcome everyone to the NPTEL course on Food Science and Technology. And this course is instructed by Professor H.N. Mishra sir, who is a professor in the Department of Agriculture and Food Engineering, IIT Kharagpur. I am Shikha Sharma and I am a research scholar in the Department of Chemical Engineering, IIT Guwahati. So this live interaction session is for the week 8 and the assignment 8 deadline is 18th. So please submit on time. The topics that we will be discussing in the today's class will include module 8 basically, which has uh, the topics related to food additives and contaminations. So it includes the definition, types and roles of the chemical additives in the food, then functional food additives and their application, then food adulteration, types, detrimental effects and detection, and then natural food toxins, allergens, anti-nutrition factors, and contaminations or contaminants, then international regulations which are there on food additives. So it includes basically 5 lectures from 36 to 40. So lecture 36 is about chemical food additives, 37 is about functional food additives, 38 is about food adulteration, then 39 is about toxins and allergens, and lecture 40 is about international regulations on food additives. So I hope you have already gone through these lecture videos. So today in this live interaction session, we'll be discussing some of the concept-based questions. So if you have any doubt, please feel ask during the class or at the end of the class. So let's begin with the today's first question. So which of the following statement is correct about the food additives? So it has two statements. Statement one is substances added to foods to discuss faulty processing as well as earn more economic profits. Second is maximum use level of any additive is basically the highest concentration which are found to be both functionally effective in a food or food category expressed as mg per kg of the food. So which statements are correct? So anyone who would like to share his or her opinion on the question? Okay. Let's see the solution part for this question. So only two statement is correct here. So basically, this statement is correct here, which is maximum use level of an additive basically is the highest concentration found to be both functionally effective and safe in a food or food category, typically expressed as mg per kg of the food. So basically, as per the FSSAI, the definition of food additive is basically it is any substance not typically consumed or consumed as a food. So it is not a substance which is typically consumed as a food or as a usual ingredient. But also it can have the nutrition value or it cannot have any nutritive value. And also the intention of adding this is to for some technological purpose, like increasing the organoleptic effects, maybe stabilizing the food or thickening the food or adding color to the food or flavors to the food, or providing some kind of texture or preservative effect or nutritional value also sometimes. These are basically added intentionally to the food during the food manufacture, processing, preparation, packaging, or transportation. This addition may result in the substance or its byproducts becoming part of the food or altering its characteristics, excluding the contaminants or the substance used solely for nutritional enhancement. So this it doesn't include the substances which are the contaminants or the substances which are just added for enhancing the nutritional value of the food, but it should provide some technological purpose, like it should provide some kind of texture, some kind of preservative effect, or some colors or the flavors, like that. It must provide some technological benefit to us when we are adding this in the food product. So any additive in a food cannot be justified if it is used to disguise faulty processing operation. So if we are correcting our faulty processing operation by the help of these additives, food additives, then it's not a good practice. So it's not considered under, like, in the good practices and the good manufacturing practices or good hygienic practices, and as per also the FSSAI definition, and it is not the correct way of using the additives. The primary purpose of an additive basically is to enhance food safety, its quality, or its functionality attributes during the processing or storage, not to earn more economic profits. So the primary purpose is to provide food some kind of, maybe it's enhancing its safety or quality or some functionality, not for the economic purpose. So if we see statement 1, so it is incorrect, because first one is also incorrect, that it is used for covering up the glitches during the processing. Also, it is incorrect that it is used to earn more economic profits. So the maximum use level of an additive is basically the highest concentration found to be both functionally effective and safe in a food or food category, typically expressed as mg per kg of the food. So this level may not match the optimum or recommended use level, which varies by application under good manufacturing practices and depends on factors like intended technique, food type, processing, and handling operations. So basically, based on the what kind of effect we want, which kind of food we are processing, and what kind of processing operations we are doing with the food, or what kind of our storage or handling practices, we'll add some then we'll going to add a particular amount of the additive or the food additive in the food, basically. And it, its concentration always will not going to use a maximum level, the highest concentration will not use, whereas as per the good manufacturing practices says that we should use a food additive in the minimal possible amount which is required for our purpose. So it is determined based on the scientific evaluation. uh, So the concentration or the maximum use level is determined based on the several studies, scientific based studies, which ensure that the additive is effective for its intended purpose, like its preservative effect or its stabilizing effect. For that purpose, it should be, we'll provide some kind of, basically all the government bodies, will WHO, FAO, Codex, and FSSAI, they have all these limits for using any food additive in the maximum limit. So the additive should be in such amount that it is effective for the intended purpose, but it risk the human health. The main criteria for approval is basically it includes safety assessment. So the additives go under basically joint FAO WHO expert committee on food additives, which is JECFA. So this under this committee, the food additive should go, and they'll assess the safety level or assess for the safety and toxicology. They'll run toxicology test on animals and then determine the what is the safe consumption amount for human. So this committee will going to decide the safety limit of a food additive. Then acceptable daily intake. So it's basically to determine if the additive can be consumed without harmful effects. So how much is the acceptable daily intake? The level is also defined by the committee. So there is this ADI level for each additive, which is like used for that additive. That is the that every day that additive should not go beyond that particular limit. Then stability of the additive. So data demonstrating the additive's stability under intended condition of use is required, especially if it's sensitive to environmental factors. So each additive, they'll be they are basically the chemicals, so they'll be uh, good stabilized under some condition and maybe pH, temperature, humidity, and that particular environment should be the environmental factor should be considered when we are using the additives. Also the technological need. So when we are using some additive, there should be the proper justifiable reason or the technological need for adding that additive. Then consumer deception. So the additive, it should not be added or should not mislead to consumers, or it should not disguise the use of poor quality raw material or undesirable practice. So sometimes uh, it may happen that the uh, processors, they can use the poor or substantial standard of like substandard quality or the of the raw materials, and to cover that they can use some kind of additive. So that should not be done as per the governing bodies. They recommend that. So the food additives, this basically are classified as preservatives, flavoring agents, color additives, texture additives, nutritional additives, and miscellaneous, which includes like chelating agents, catalysts, enzymes, antiforming agents, etc. And these additives, they are basically used in the particular amount, and every additive in it is having, if it is approved by European standards, there will be E number. So E510 like that. And if it's FSSAI approved, mostly we can see at the back of the label, any chips or any item which is packed like biscuits or anything, INS number. So we see mostly number, and E number means if it's approved by European Union. So basically here statement second is correct. The maximum use level of an additive basically is the highest concentration found to be both functionally effective and safe in a food or food category, and it is expressed as mg per kg of the food. Okay, let's see the next question. Chelating agents are primarily used in the food to neutralize free radicals, act as nutrition or nutrient supplements, stabilize metal ions to prevent oxidation or enhance flavor. Anyone who would like to answer this question? So most of people are saying C. So C is the correct answer. All of you are correct. So chelating agents, they are primarily used in the food to stabilize metal ions to prevent oxidation. So metal ions, they are basically in their free form can accelerate lipid oxidation and rancidity and degradation of food quality. So what will going to happen? These metal ions, they will going to accelerate the lipid oxidation and accelerate the rancidity process and degrade the overall food quality or spoil the food. So chelating agents or sequestrants, they are basically going to bind with the free metal ion like this diagram. This is the metal ion. It is being bind by the chelating agent. So the chelating agent binded it, this metal ion. So it forms metallic chelate. So basically, metal ions like iron, copper, they're going to be accelerate the lipid oxidation process, so they needs to be bind using the chelating agents. So these uh, Fe and copper like these, they are the common catalyst and they are going to oxidize the reactions in the food system. So they need to be bind using the chelate ions. So when these metallic ions are released through hydrolysis or degradation, they are free to precipitate the reactions that lead to food discoloration or oxidation or rancidity and uh, turbidity and flavor changes. So these chelating agents, they are going to bind with the metallic ions. So they are basically the organic macromolecules which owning to several functional groups, they are going to able to establish more than one chemical bond with the metal ion and stabilize it and increase its solubility. So if we see here in the diagram, this EDTA is a chelating agent. So it is binding one metal ion like this, Na2 plus. So further, EDTA is also binding this Fe3 plus. So these chelating agents like EDTA and citric acid, they are the commonly used in the food products to prevent this oxidation or this spoilage. So ensuring the extended shelf life of the product and maintaining the product quality. So these basically serve as a scavenger of metals by which catalyze the oxidation. So they are not antioxidants, but they are the antioxidants synergists. So basically these chelating agents, they are not the antioxidants, but if they function or they work with metal ions, they will going to help or the antioxidants and chelating agents, they will act together and they will produce the synergetic effects. So citric acid and its esters in propylene glycol solution are effective synergists in lipid system. Like this is the example of this. And second is that polyphosphates and EDTAs, they are the common chelating agents which are used in canned seafoods. So basically, EDTA and citric acid, these are basically the common chelating agents which are used in the food system to enhance the shelf life. So in this picture, there is this diagram showing that Fe3 plus, which is this, is replaced. So here it is being replaced from like Ni is replaced with Fe3 plus. So this is Fe3 plus is replacing Ni2 plus, and when it is reacting with DTC, so it is the Ni, when Ni is reacting with DTC, it is going to precipitate. And when DTC is going to react with the complex of EDTA and Fe3 plus, so it will not precipitate. So basically what is happening, this uh, uh, this Fe3 plus is basically acting as one of the ion which is replacing the Ni2 plus and making the Ni2 plus uh, and DTC reaction to get, they'll bind and they'll going to precipitate. So Ni2 plus reacting with DTC or making the metal chelate, and it is getting precipitate and getting reaction. So like this, uh, they are these basically these are the compounds which are going to basically act as a chelating agents, because this EDTA is basically a chelating agent and it is binding Ni2 plus very strongly. And if we do not replace F with uh, this with Fe3, because Fe3 plus and EDTA will more strong reaction or more strong complex. So Ni2 plus is, and after that it will precipitate using DTC in here. So like this, chains are basically going to react with metal ions and they're going to basically stabilize the metal ion so that oxidation not process. So answer C is correct here. So this is basically, it is this diagram is showing how the complex with EDTA forms. So this is the basically with, here is the metal ion and this is the one molecule of chelating agent and another molecule of chelating agent, and it is going to bind the chelating agent, bind the metal ion and form the metal ion complex with the chelating agent. Okay, let's see this question. Match the chemical which is there in the column 1, EDTA, aspartame, catalase, and vitamin D. So the column 2 is having the its functions or the characteristics in column 2. So basically, one is enzyme, second is chelating agent, then third is nutrient supplement, fourth is non-nutritive sweetener. So we need to match here the chemical with its function. Anyone who would like to answer this question? Okay, Anju is saying D. Anyone else? So D is the correct answer here. So basically EDTA is this molecule. So EDTA is widely used as a chelating agent in the food, as we just now discussed, and the industrial applications. So it basically binds with the metal ions like the iron and the calcium, and it will form the stable complexes which prevent the oxidative reactions or scaling in the solution. So this is the EDTA. Basically, it is going to react with the metal ions, and it will form metal chelate as a metal chelate complex. So EDTA is associated as its function is chelating agent. Then aspartame, basically it is an artificial sweetener that provides sweetness without significant calories. So it is a non-nutritive sweetener because it provides the sweetening effect, but it will not provide the calories. So it is basically used in the sugar-free products or the products which claim to be used for diabetic people and for the obese people. So it is having basically it provides the non-nutritive sugars. They provide less than 2% of the calorific value of the sucrose for equivalent unit of the sweetening capacity. So if uh, the sucrose is providing the same level of the sweetness, so it provides just basically less than 2% of the calorific value of the sucrose only. So it is around 180 times more sucrose. Very sweet, but it will not going to provide the calorie. So it is basically used for the products. So this is basically aspartame. So aspartame is basically related to D, non-nutritive sweetener. Then antioxidants basically are the substances basically that will going to serve as a defense against free radicals. So which are byproduct of the metabolism or result from environmental factors like pollution. So these free radicals, they're going to damage basically the DNA or the cell membrane and going to lead the oxidative stress and an increased risk of the chronic diseases. So these antioxidants, they will going to neutralize these free radicals, safeguards the cell. Antioxidants are like to donate electron to this unpaired or the free radical paired electron so that the to stabilize the free radicals so that they're not going to damage the DNA or the cell membrane. So these antioxidants, they are basically can be enzymatic or they can be non-enzymatic. The enzymatic can be primary, which includes this catalase, and the secondary, which has basically the glutathione reductase or glucose 6 phosphatase, phosphate dehydrogenase, and non-enzymatic antioxidants, they includes basically the minerals, vitamins, carotenoids, organosulfur compounds, antioxidant cofactors, polyphenols, low molecular weight antioxidants, and these polyphenols further they will be classified into flavonoids and polyphenol or phenolic acids. So in flavonoids we have 5 subcategory, which is flavonols, isoflavonoids, then flavonols, then flavonols, then basically anthocyanins, cyanidins, basically anthocyanidins, then flavones. So it has 5 further category, and phenolic acids, it can be hydroxycinnamic acids and hydroxybenzoic acids. So as we discussed that catalase is basically a primary enzyme or enzymatic antioxidant. So this catalase is basically a biological enzyme that breaks down the hydrogen peroxide H2O2 into water H2O and oxygen O2. It is crucial in protecting cells from oxidative damage caused by reactive oxygen species and is used in food processing to remove residual hydrogen peroxide. So basically, catalase is going to react with H2O2 and form H2O and O2. That way, it is going to help with the and perform the action of antioxidant. This is basically the molecule of catalase enzyme. So here catalase is basically an enzyme which is going to act as an antioxidant. Then vitamin D is basically a nutrient supplement essential for basically bone health and calcium metabolism. So it is often added to fortified foods such as the milk, cereals, and margarines to prevent its deficiency, like rickets in the children and osteoporosis or the less density of the bone in the adults. In commercial form, vitamin D is found as fat-soluble crystals for use in high fat content foods and also encapsulated stabilized versions of fortificants. So vitamin D is like this, and it can be basically uh, it can be get from basically raw milk, tuna fish, or beef liver, egg yolks, sunlight, mushroom, salmon, oil, like this. From these are the sources of vitamin D, and vitamin D is basically recommended. The recommended dietary allowance for RDA for vitamin D is basically given in this table. So for adults, basically for males, it requires 600 IU, and for males and females, it requires around 600 IU. So basically, this vitamin D, how we produce is so from the sunlight. So basically, what happens in the food, we have vitamin D2 and vitamin D3, and it will go in the liver. So if it's like it's in the form of basically it activates it basically activates uh, using the UVB, which is sometimes we say that we get vitamin D from sunlight, but basically what happens, vitamin D activates the form, like convert the passive form into the activated form. So basically this 7 dehydrocholesterol, it will basically it is there in the skin. So it is going to, when we get the sunlight, so it will be converted into cholecalciferol, which is vitamin D3, and it will going to be present like stored in the liver. And also if we get vitamin D2 and D3 from the food directly, it will go into the liver. After that, it will be converted into basically this form, which is 25 hydroxy vitamin D3, and then it will be in the kidney, and further it will convert into the biologically active form of vitamin D, which is 1,25 dihydroxy vitamin D3, which is the active form, actually the active form of vitamin D. So there are different foods which are nowadays fortified with vitamin D, because vitamin like many people has this deficiency of vitamin D. So milk is basically can be fortified with vitamin D, and then soya milk, almond milk also, and sometimes cheese also be fortified with vitamin D. Cereals also, and yogurts, low fat like that they can be fortified, and so that the deficiency or the nutrient of vitamin D can be supplemented to the population which is having its deficiency. So vitamin D is basically a nutrient supplement. So here option D is correct. Okay, let's discuss this question. Mixed antioxidants act synergistically. Synergistic action improves the efficiency of antioxidants in preventing lipid oxidation. So we have two statements. One is assertion and one is reason. So assertion is saying that mixed antioxidants act synergistically, and reason is that the synergistic action it will going to improve the efficiency of antioxidants in preventing lipid oxidation. So which one is correct, and which is the correct option provided here? Anyone who would like to answer this question? Okay, so let's see the answer. So answer A is correct, that both assertion and both reason are correct, and reason is the correct explanation of this assertion. So basically lipid oxidation is basically a chain reaction where several changes happen at the same time that leads to basically density and quality degradation of the food products. So the antioxidants, when used in the mixture, they can act as primary and secondary antioxidants. So the primary antioxidant can include like BHA, BHT. It can scavenge free radicals, while secondary antioxidants like the ascorbic acid, it can regenerate the primary antioxidants, or it may also chelate metal ions, further reducing the oxidative stress. So by this mechanism, mixed antioxidants, they can effectively interrupt the chain reaction of the lipid oxidation and prevent the formation of the free radicals and also the oxidative degradation. So both the assertion and the reason, they both are correct here. And also the reason is a correct explanation of assertion, because the mixed antioxidants, they can act together or synergistically. One can act as a primary antioxidant and attack directly or act directly on the free radicals, while secondary antioxidants like the ascorbic acid, it can regenerate the primary antioxidants. Also, it can chelate metal ions. So it will they both will going to act synergistically. So option A is correct here. So basically antioxidants can work with the 5 mechanisms. One is basically it is going to quench the directly quench the ROS, which is basically reactive oxygen species, by radical scavenging method or mechanism. So it can also like directly attack or directly uh, quench with the ROS, which is reactive oxygen species, and can neutralize it. Also, it can uh, donate basically H plus, oh sorry, H ion, H free radical or H free radical it can give and stabilize. Also, it can inhibit the oxidative enzymes itself. so it can directly inhibit these oxidative enzymes. Then it can also basically uh, relate these transition metals like this Cu plus, Fe2 plus. These are the transition metals or the cofactors. It can chelate these metal ions, which will going to convert this basically, which will going to participate in the oxidation reaction. So antioxidant can directly react with these metal ions also. And fifth is the it can basically repair the damaged cell components like the DNA or the proteins or the lipid membrane lipids. So it can also directly repair these. So overall, there are two mechanisms of work for antioxidant. One is chain breaking mechanism by which the primary antioxidant it basically donates an electron to the free radical directly, which is mechanism number present in the system as like beta carotene, vitamin C, vitamin E, or it simply harmless product. So it may like one is that the antioxidant will going to directly quench basically, or directly it will going to quench with the ROS or free radicals, or it will directly scavenge the free radical and make the stable molecule. The second action is the preventive antioxidant enzymes like superoxides, dismutase or the catalase, and glutathione peroxides. So they prevent the oxidation by reducing the rate of the chain initiation. So they can also prevent oxidation by stabilizing the transition metal radicals like the iron and the copper, like fourth mechanism. So here basically antioxidants mechanism we are discussing, that these are the five mechanism, five ways antioxidant can function. So let's see the next question. Hope so far is clear to everyone. If anyone has any doubt, please feel free to ask. So let's discuss this question that uh, blank functions as a natural emulsifier in various foods and industrial applications. Pectin, gelatin, cellulose, and lecithin.
And okay, Akshi, what is rancidity?
Hello.
rancidity means क्या होता है?
Uh, your voice is not clear. It's breaking. Can you please ask again? Muskan, you are saying something, right?
Yes, ma'am. मैं पूछ रही हूँ कि rancidity means क्या होता है?
Your voice is not clear, Muskan. Can you please type what you want to ask?
Rancidity.
Rancidity.
Yes, ma'am.
So, what about rancidity you want to know?
Means rancidity का मतलब क्या होता है?
अच्छा, रेंसिडिटी मीन्स सो क्या होता है, हमारा जो फैट होता है, जितने भी फैट वाले सब्सटेंसेस होते हैं जिनमें बहुत ज्यादा ऑयल होता है, फैट होता है, तो इनमें क्या होता है ना, दे हैव दिस अनसैचुरेटेड बॉन्ड्स लाइक दिस सी डबल बॉन्ड्स
Yes, ma'am.
like these.
Unsaturated.
Yeah. So what will going to happen? They'll going to break down when there will be some free radical is there. Suppose I am having some free radical, like this is my free radical. So what will going to do? Just say H2 hai. So it can produce two free radicals like this. One can go here, bind with this, one can go bind with this. So it can form, like it can change the structure. So rancidity in that's kind of a like um, the fat, it goes basically under oxidation. So like this, if there is oxidation O and O, so this oxygen free radical, it will going to attack this double bonds of unsaturated uh, unsaturated fatty acids. So it will going to form the CO bond. So that will going to like oxidation of the fat. So if the fat is getting oxidized, like that is a spoilage so it will go get rancid. So rancid, there is this rancid taste or rancid smell will be there in the fat. That means it's spoiled.
Yes, ma'am.
Is
Thank you,
it
ma'am.
clear, Muskan?
Yes, ma'am.
Okay.
Thank you, ma'am.
Okay, we were discussing this question about natural emulsifier. So let's discuss. So we got two answers as D, so which is lecithin, Prithinga and Jitnyasa. So we got two answer from them, which is same D, lecithin. So I think they both are correct only. So lecithin is the correct answer here. So lecithin is a naturally occurring compounds which is commonly derived from the soybeans or the eggs or the sunflower seeds. So it is basically this structure is for the lecithin. So it is basically having this phospholipids. So and function as an emulsifier. It basically function as an emulsifier and maintain for stabilizing the mixtures like oil in water or water in oil that can separate if we'll not add the lecithin. So basically, if we have oil in water, so oil and water may separate like this. So to make the uh, this is a to make this solution as a homogeneous solution, we need some kind of emulsifiers like the lecithin, which will going to help in the emulsification process. So which will going to mix this oil and water, which are the two different phases, which will going to help with the solubilization of these two phases to form the stable emulsion at least. So lecithin is the correct. Okay. Next is the leavening agent. So which of the following statement is correct regarding the leavening agent? The statement one is saying leavening achieved by baker's yeast by this reaction. And second is leavening is achieved by chemical leavening agents by this reaction. So which statement is correct here? So Jityasa is saying that both the statements are correct here. Okay, let's see the solution. So here only B answer is correct. That is only second statement is correct. So let's see. So leavening agents, they are basically can be used in the bread and will help to provide the fluffiness in the bread. So leavening agents, they are the substances which are going to release the gas in the dough or the batter under appropriate condition of moisture and temperature. So they're going to release the gas, so which will going to basically expand or along with the expansion of the entrapped air and moisture vapor. So what happens? Basically what will going to happen, these leavening agents are the substances. They can be any leavening agents, they can be physical, they can be chemical, or they can be biological. So they are the substance which are going to have or they are the substance which will going to give the dough or the batter this air. So what will going to happen? Uh, this leavening agents, they will act under certain kind of moisture or the temperature. So when they'll get certain moisture, certain temperature, or certain time period, when we leave the dough with the leavening agent, it will going to release some kind of gas. So when the gas will be released, so uh, there will be this expansion of the entrapped gas, also the moisture, and also the moisture. So it will overall going to give the porous or the cellular structure to the finished goods, like this structure. So it tenderizes the crumb and contributes to the aesthetic enjoyment of the final product by giving it uniform cell structure, bright crumb color, soft texture, and enhanced palatability, like in the bread. So the crumb will be having some uniform cell structures. It will be fluffy and soft texture and the bright color. So this leavening agent will going to do this. So physical leavening is when we are mixing, like when we have the cookies. So when we make the or when we have the cream, when we are whipping the cream. So when we mix, so some agent will going to be enwrapped in the cream, like when we are mixing very rigorously. So that is physical agent. Chemical means that some chemical mixture or compounds will be there that will going to release the gas. So it includes basically the baking soda or the baking powder, which basically generates CO2. So when they react with the moisture and these uh, mixtures or the compounds, when they react with the moisture or the heat, they're going to produce CO2. So the gas produced is basically held by the fat pockets, gluten's, and the starch, which will going to make the baked product little rise enough. So this is basically the chemical agent, which will with the moisture and the heat, it will going to produce this CO2, which will going to function as the leavening gas. So this is basically baking soda formula, right? Then biological agents are also there. So biological agent means microorganisms will be there, which will going to produce gas through some kind of metabolic process. So leavening action is the increase in the low volume, mainly due to the production of CO2. So here also CO2 is producing by the microorganism, but here by the microorganisms, like very popular is baker's yeast, which is Saccharomyces cerevisiae. So it basically ferments the sugar, which is basically the this glucose or sucrose, like this like C6H12O6, like this reaction is there. So and it will going to produce ethanol and CO2. So here this is wrong. This should be glucose is converted into ethanol and CO2. So this statement 1 is not correct, whereas second is correct. Okay, I hope everything is clear so far. We are moving to this next question. When we are adding curcumin to the food products, it provides both the color and the health benefits. Reason is that curcumin is a potent scavenger of free radicals like the reactive oxygen species ROS and reactive nitrogen species RNS, which going to damage the cell and the tissues. So we need to tell about assertion and reason if it's correct or not. So Anju is saying B. Aman is also saying B. Jitnyasa saying A. Okay, let's see. So A is correct here. Basically, that both are correct, and reason is the correct explanation, providing the correct explanation of assertion. So basically, curcumin is a bright yellow chemical compound which is produced by the plants Curcuma longa species, and it is the principal curcuminoids of turmeric. So turmeric is basically a ginger family. It belongs to ginger family. So this curcumin is basically a potent scavenger of free radicals such as reactive oxygen species, and it enhances the activity of endogenous antioxidants like SOD, which is superoxides, dismutase, also the catalase, glutathione. So thereby it strengthens the body's defense mechanism against the oxidative stress. So this is basically curcumin from the turmeric. So due to these effects, it gives health benefits such as basically anti-inflammatory agents, antioxidants, antimicrobial agents also, then anti-diabetic, cancer preventing, then for neuroprotective actions, and for anti-allergic also the protects the heart health also. So basically here the curcumin is basically provides color which is yellow, and it has health benefits because it is a potent scavenger of free radicals, ROS and RNS, and it protects the damaged cell tissues also. So A is correct here. Okay, so in column 1, in this question, we have this column 1, which is having chemical additives like lecithin. Then we have azodicarbamide, and then we have cochineal, and we have titanium dioxide. So in this column 2, we have their functions like emulsifiers, flour improvers, insect-based colorants, and synthetic mineral-based. So we need to match here column 1 with column 2. Anyone would like to answer this question? I got C to answer. Okay. C is the answer. Yes, C is the answer. So C is correct answer. So lecithin, basically we discussed that it is basically an emulsifier which is derived from uh, yeah. So basically lecithin, we discussed that it is basically a natural emulsifier. So it often derives from the soybean or the sunflower seeds, and is basically stabilize the mixtures of oil and the water by reducing the surface tension, commonly used in the products like chocolates, margarines, and baked goods. So this is basically the lecithin structure. So lecithin basically is a has a chemical structure which is having phospholipids, and it has so which are the esters of choline, ethanolamine, inositol, serine and the fatty acids. So here it is having fatty acid residues as R1, R2. So if we see the emulsification process of the lecithin, so the above one, if it's oil and water, so it basically, because oil is less dense than water, so it will be at top, floats on the water surface. So this lecithin, it will be having one hydrophilic end and hydrophobic end. So hydrophilic end means it has hydrophilic phosphate and hydrophobic fatty acid tail. So it is this part, and then the fatty acid part is basically R1 and R2, which is the fatty acid residues. So they are basically the hydrophobic tail. So it will going to, when we put this lecithin into this solution, then what will going to happen? It will form micelle. So in micelle, what happens, that the with the water, which is the water, so the hydrophilic part, which is this part, will going to interact with water, and the hydrophobic end will going to interact with the oil, which is outside. So it will form this micellar kind of structure, and this way this uh, oil and water, they will going to basically form a stable emulsion. So this lecithin's epiphilic property decrease the surface tension between these two unmixable or oil and water solution, and make a stable heterogeneous dispersion. So basically lecithin here act as an emulsifier. Then dicarbonamide, this is basically a synthetic additive which is used as a flour improver and the dough conditioner, and it is going to improve the rheological property of the dough. So if we are adding this compound in the dough, so it will improve the basically the strength of the dough, and it improves the its elasticity and results in the uniform bread structure. So it the rheology of the dough. So next is the food colorants, which is these two, titanium dioxide and cochineal. So cochineal is basically a natural red colorants which are derived from the dried bodies of the cochineal insect. So this is the insect, cochineal insect, red color. So from this basically red color is obtained naturally, which is used in the beverages, candies, and the cosmetics. And titanium dioxide, which is of the white color, so is a white synthetic mineral based pigment, is used as a food colorant, and it provides opacity and brightness to the products like candies, cheese, frostings, and toothpaste also. So this azodicarbonamide, this is a flour improver. Cochineal is a insect based colorant, and titanium dioxide is a synthetic mineral based colorant. So answer C is correct here. Okay, so in column, next question, column 1 will have is having adulterants like papaya seeds, urea, brick powder, and soapstone powder. In column 2, we have the food products like chili powder, wheat flour, pepper, and milk. So we need to match the adulterants with in which these we will going to add with the different food products. So we need to match these. Anyone who would like to answer this question?
हम ब्रिक थर्ड का ए
Uh, Third, brick powder is powder. Okay. Anju is saying A is the correct answer. Okay.
यूरिया मिल्क
Urea is added to, yes. Jitnyasa also A. So we got A as our answer since two people are saying. Okay, let's see if it's correct or not. So it is correct, basically. So papaya seeds, they are basically resembles to the black pepper, so in appearance, and are sometimes mixed with it to increase the weight and volume fraudulently. So consumers basically will think that basically sometimes these processors they add this papaya seeds which into the black pepper so that the volume and the weight can be increased of the black pepper. So consuming these papaya seeds as pepper can cause digestive problems and irritation due to their non-edible nature. So these papaya seeds they are non-edible in nature, and if human will going to consume it as a black pepper, so they can have some kind of digestive problems. So if we want to separate this papaya seeds from black pepper, so what we can do, we can put it into directly water. So if it's float, so it will be papaya seeds, and if it sinks, that means it is black pepper. Urea basically is added to the milk to increase its nitrogen content so that the this urea will going to mimic the that the or if we are using more urea in the milk, that means it will falsely saying it is having higher protein level in the quality test. So urea natural milk, it is from around 20 mg per 100 ml to 70 mg per 100 ml. But if we are adding adulterating urea in the milk, the level can go above 70 mg per 100 ml in the milk, which indicates that it is a added urea. So urea, if we added in the milk, it can harm the kidney function and lead to digestive disorders, especially in children and infants. So the addition of urea to milk can be detected by using para-dimethyl aminobenzaldehyde, which is DMAB test. So this method is basically used. Uh, we need to add urea base. We need to like this method is basically used to detect the urea in the milk. So what happens when this DMAB added with the urea, it will form a yellow green color compound. So if we are it into the like if we are adding DMAB with the urea, so if we are getting the yellow color complex compound in the low acidic solution at the room temperature, so that means it is having urea. This milk is having urea in it. Like if we add 10 ml of the milk with 10 ml of the this trichloroacetic acid TCA, so 24% weight by volume. Then if we are filtering with the Whatman filter paper and the filtrate, if 5 ml of the filtrate we are adding with DMAB with the same amount 5 ml to 5 ml of 1.6%, so it will form yellow color compound. And if we see in the UV, so at 420 nanometer it will absorb its wavelength. So we can identify the concentration of the urea in the milk when with the UV method. Next is the brick powder. So it is mixed with chili powder. So this is the red chili. This is the brick powder. So if we mix, we'll not able to separate it. So it is added basically by the processors to in bulk the quantity and making it appear more vibrant in color. So the brick powder, it is also non-digestible or non-edible, and it can cause stomach irritation, ulcers, and long-term damage to the digestive tracts. So the chili powder, if we will add in the basically water, so the chili powder will going to float and the brick will going to sink. This is brick powder. This is chili powder at the top. Soapstone powder, which is magnesium silicate, it is mixed with wheat flour to increase the bulk weight at a lower cost. So wheat flour, in this we add soapstone powder, or the adulteration is from soapstone powder. So soapstone powder, basically it is not digestible and may cause gastrointestinal issues and potentially long-term toxicity. So HCl is basically added. So basically this is the HCl test. So if we are adding HCl in uh, the soapstone powder or the adulterated wheat powder, wheat flour, so if it's forming effervescence, this effervescence is there, bubbles like this, so it means that it is adulterated. This wheat flour is adulterated basically. So urea is in the milk, brick powder and soapstone wheat flour. Okay, so in this column one we have detection techniques, HPLC, CE, NMR and PAGE. So in column 2 we have the working principle of different uh, techniques. So we need to match here. That's here it's the separation. In A, the separation is there based on the size and charge under electric field, and B is using the magnetic field to determine molecular structure based on atomic environment. C is separates compounds based on polarity and interaction with stationary and mobile phase. And D is uses a gel matrix to separate macromolecules based on their molecular weight and charge. Anyone who would like to answer this question? Aman is saying D. Jitnyasa also D. Okay, let's see the solution. So they are correct. D is the correct answer here. So when we are discussing about these detection techniques of the adulterants, we have various approaches for detection of the adulterants. Like we can have the physical techniques, chemical or the biochemical techniques, and the molecular based techniques. So the physical techniques includes basically the structural analysis by the microscopes, and the physical analysis. And in the chemical or biochemical assay, we can analyze using chromatographic techniques, spectroscopy-based techniques, electrophoresis, and immunology. And molecular techniques includes PCR, sequencing, like these techniques includes in molecular techniques. So here we are basically talking about these chemical or biochemical techniques like HPLC, and then we are discussing about NMR, which is spectroscopic techniques, then PAG, which is electrophoresis and capillary electrophoresis. So this is electrophoresis based. So here, as we discussed, we are discussing about chromatographic techniques, spectroscopy, immunology. We have these techniques, basically electrophoresis. So basically we are discussing these three techniques, chromatography, electrophoresis, and spectroscopy. So in basically HPLC, it separates compounds based on the polarity and their interaction with the stationary phase, usually a packed column and a mobile column or mobile phase, which is a liquid solvent. So there are in HPLC, one is this is HPLC. So in the column, which is this column, HPLC column, it has basically two phases. One is stationary phase and another is mobile phase. So it separates the compounds based on the polarity, and how this compounds which we are injecting, like with the solvent. So solvent will be pumped, and we'll inject our sample in the solvent, and it will go through the column, and then column will separate, and based on the different retention time basically. So if the compound is like very like it's a polarity, based on its polarity, so if the stationary phase we have, so based on the polarity, some will elute faster, so their retention time will be lesser. So they will be at here in data acquisition, their retention time will be lesser, and some will be attached with the column or the stationary phase, or they'll interact, so they'll come later, so their retention time or their elution time will be later. So based on this, the compounds will be separated. So the compounds are retained and eluted at different rates depending on their chemical properties, like about their polarity and their affinity towards the stationary phase. So if it's more like more interaction with the stationary phase, so it will come later, or its retention time or elution time will be more retention time. So the HPLC can accurately identify the types and concentration of different type of the food degrading agents. So HPLC, it can be coupled with the detection systems, different type of detection systems, like this detector can be UV based, it can be mass spectrometer, MS, or any like RF, any different detectors, radio frequency. So it can be any detector which it will be chosen based on which kind of adulterant we want to detect. So HPLC is basically related to separation of the compounds based on the polarity and interaction with the stationary and the mobile phase. Then we have the HPLC of four types: normal phase, reverse phase, ionic phase, and size exclusion. So normal phase is when the column packing is polar, which is made of silica, and the mobile phase is non-polar. So it is used for water sensitive compounds, geometric isomers, cis trans isomers, and chiral compounds. And this reverse phase, basically this is the normal phase. So it is having the stationary phase as the polar, and its mobile phase is non-polar. In reverse phase, the reverse will going to happen. So the column is non-polar, which is C18 column, and it is basically this reverse phase only used for in basically used in the for the food compounds detection. So the mobile phase is basically water, and miscible solvent may be methanol. So it can be used for polar, non-polar, ionizable, and ionic samples. So here basically the mobile phase will be basically polar, and the stationary phase or the column will be non-polar. And in ion exchange, basically column packing, it contains some ionic compounds. Maybe this packing will have some ionic compounds like positive ions or maybe negative ions. And the mobile phase is basically buffer, and it is used to separate ions like the anions from the cations. It will separate. So if there is positive charge, it will attract all the negative charges in the column, and the positive charges will go out and elute faster, and the negative charge which will be attached with the stationary phase or the in the column, it will come later on. Then size exclusion is, it basically it is size exclusion is basically used for the polymers, detection of the polymers molecular weight. So basically it separates the molecule, diffuses into the pores of a porous medium, and are separated according to their relative size to the pore size. Larger molecule elute faster, and the smaller elutes later. So what happens here? This is the column. So there will be this larger particles, they will come faster, and the smaller particles, they will going to bind, they will going to attach, or they will going to go into the smaller like capillaries, they will fill in the smaller capillaries, whereas the larger particles, they will not fit into the capillaries and they will come faster, whereas the smaller particles which are there in the capillaries, they'll travel this long. So the larger particles elute faster and the smaller one elute later on. Then capillary electrophoresis method. It separates molecules based on the size and charge when it is subjected to electric field. So basically, uh, in the capillary electrophoresis, the charges, this is the anode, this is cathode. So electric in under the influence of electric field, the molecules will be separated like uh, when the molecules will pass through this. So capillary zone electrophoresis has been utilized to determine the adulteration of cow milk in goat milk products and adulteration in basmati rice. So basically, under the influence of this positive and the negative charge or the electric field, the uh, adult going to separate in this capillary. Particles will move here in this long capillary, they'll separate and the detector will go like this. Because so the electrophoresis, basically one electrophoresis is capillary electrophoresis. So it comes basically there's capillary electrophoresis, moving boundary electrophoresis, in which this capillary electrophoresis comes, isoelectric electrophoresis and isostachophorosis will also come. The second one is zone electrophoresis, in which this basically paper electrophoresis, cellulose acetate membrane, and gel electrophoresis will come. In gel electrophoresis, there are two, which is agarose gel electrophoresis and page, which is polyacrylamide gel electrophoresis. So this page is basically specific type of electrophoresis, a gel matrix to separate macromolecules like proteins, DNA based on their molecular weight and charge. Basically, gel. Here is sample loading. There will be this cathode and electrode, which is providing like the electric field. So in this gel, basically, this is the gel. Here, the protein will migrate. So it will migrate like this. So the larger protein molecules will, and the smaller will elute faster. So this kind of SDS stage we can see uh, during the this analysis. And fourth is the NMR technique. So this NMR is basically, it is using this magnetic field and radio frequency pulses to study atomic nuclei. So basically, it identifies the molecular structure or the new molecular by analyzing. If we don't know what is the, this basically this technique is used to identify the unfamiliar molecules which are the new to our like knowledge. So basically it identifies molecular structure by analyzing how much hydrogen is there, carbon is there, or other atoms in the compounds. So based on analyzing how much carbon, hydrogen, and other atoms are there, so it will find the it will form the molecular structure, and from the molecular structure we can identify, okay, this compound is there. So it will be used in the unfamiliar samples. So in the sample tube, we'll have some kind of the magnetic field, and it will be helping for the detector. It will see some, it will form some fingerprint, and this kind of spectra we got in NMR. And based on that, how much what is the structure, what is the A compound peak, B compound peak, like that H compound peak. So we see and we try to make the chemical structure of the unknown compound. So it basically exploits the magnetic property of the atomic nuclei to provide the detailed information about a molecular structure, its dynamic and its concentration. So the entire phenomena of NMR, it rests on the quantum mechanical property of certain atomic nuclei called the nuclear spin. So for nucleus to be observable, it must have non-zero quantum spin. That means it should have plus minus 1 by 2 spin, or it should have some spin. It should have, it should not have zero spin. So if we want to identify it, such as hydrogen, so 1H, and carbon 13C in NMR spectrum. So we have two kind of spectra, 1H, 13C. This spin creates a small magnetic moment, effectively turning the nucleus into tiny bar magnet. So based on providing the magnetic field to the sample, we can identify how the atomic nuclei is spinning, what is the nuclear spin, and based on that we can identify the how much hydrogen is there, how much carbon is there, and we can form the chemical structure, and we can identify the overall compound, which compound is present. So the capillary electrophoresis is related to this, that it is separating based on size and charge under electric field, and NMR is basically, it is related to use of the magnetic field to determine the molecular structure based on atomic environments, and this PAGE is using the to separate macromolecules based on molecular weight and charge. I hope this question is clear to everyone. We are moving to this next question. Which of the following statements are correct? So calcium carbide is used as an artificial ripening agent for fruits, but can cause health hazards like cancer and gastrointestinal disorders. Second is GC is commonly used to detect starch adulteration in powdered spices. Third is international adulteration involves the deliberate addition of inferior substances for financial gain. And fourth is urea is common adulterant which is used in the milk to increase its protein content artificially. So we need to tell which statement is correct here. Anyone who would like to answer this question? So Aman is saying A, 1 and 3 are correct. Anju is saying C, 1, 3 and 4 are correct. And then Ritinka is saying D, 2, 3 and 4 are correct. Jitnyasa is saying C, 1, 3 and 4 are correct. Okay, let's see. So C is correct, 1, 3 and 4. So basically this calcium carbide, which is this, is often used illegally to ripen fruits such as mangoes, bananas, and papayas. It is commercially available as a green or brown technical grade, and it releases the acetylene gas, which is the analogous of ethylene. So basically, this is the calcium carbide. When it reacts with water, it forms This acetylene gas, which is used for the fruit ripening, or we can see it is used for the tomato ripening. And this white color compound we can see here is a calcium carbide deposition on fruits and vegetables, which is not good for the health. This is the acetylene gas. This is the structure of this. So basically, residual traces of calcium carbide, which is there as a white deposition in the fruits or the vegetables. We can see here white deposition in this tomato. So in the fruit can lead to this severe health issues leading to gastrointestinal irritation, neurological symptoms, potential carcinogenic effects due to arsenic and phosphorus impurity in commercial grade calcium carbide. So it can not be good, it is not good for the health. So that's why it's not recommended to use calcium carbide for the ripening of the fruit. So it basically facilitates early fruit harvesting, but it is used by the processors because fruit can ripe early and can be harvested early, and also the color can be developed faster, taste can be developed faster, and the fruits can also we can get in seasons also. That's why these kind of practices are done by the processors. So calcium carbide is basically an artificial ripening agent for fruits but can cause health hazards. Then urea basically is used in the milk to mimic higher protein levels by increasing the total nitrogen content detected during the protein analysis, which is also true. We discussed it in the previous question also. Then intentional adulterants, they are basically food adulterants can be added intentionally, unintentionally, and metallic adulterants. So it can be classified into three categories. So intentional adulterants, they are basically added by the like they are added or they are basically uh, put into the food to change the natural properties knowingly or deliberately. So it is a fraudulent practice where the cheaper substances are added to the food to increase its volume or weight to get more profits, which is not a very good practice. Like we add some food additives, preservatives, ripening agents, or pesticides, or sand, marbles, or chalk in the food product. Then unintentional adulterants are the one which is because of the carelessness or ignorance or negligence, basically in the when we are processing it into the processing facilities, like there can be microbial contamination and larvae in the food, rodents droppings can be there, and pesticide residues are there, but they are unintentional. And then is the metallic adulteration. So metals can be added either intentionally or accidentally, like arsenic, lead, mercury, or tin. So this statement is also saying correct that deliberate addition is there to get the financial gains. Then GC basically is used for analyzing the volatile compounds like the essential oils in the spices. So it is used to analyze the animal fats also, vegetable fats also, technique. So the starch basically it is detected using examination or iodine test. So when we add iodine in the starch solution, it will form blue color, blue black color compound, blue black color complex it will form. So that means that starch is there. So GC is basically we use the volatile compounds put in the column and it will be further detected. Basically, these essential oils can be tested. So second statement is not correct because it is not used to detect the starch adulteration. Okay, so let's see this question. Which among the following techniques like FTIR, GC, ELISA or capillary electrophoresis is commonly used to detect melamine adulteration in milk products? So this is the melamine compound which is put into the milk products. So as an adulterant. So which technique we can use to identify it? So we got Jitnyasa C, M and D, C and D, Eliza and CE, Muskan B, which is GC. Okay, let's see the solution. Which one is? So basically, melamine, Eliza is the correct answer. So melamine is basically a nitrogen-rich compound which is added to the milk or milk-based products to increase its apparent protein content when tested for nitrogen levels. So, melamine consumption is basically causing serious health issues like kidney damage and renal failure also. So it should not be added, but it is being added to increase the nitrogen content in the food or in the milk products. So this ELISA, which is the biochemical technique we discussed previously, this is the immunological assay. So this kits, ELISA kits like this can be used of this melamine compound. So it can be basically four types: direct, indirect, sandwich, and competitive ELISA. So here, what are they? This technique uses antibodies to detect specific compounds in the complex mixture with high sensitivity and specificity. For melamine detection, specific antibodies will going to bind with the melamine compounds or molecules and interact with this, and and then measurement will be there of the presence and the concentration very accurately. And from this technique, ELISA technique, we can uh, accurately identify the melamine contamination or melamine content in the milk. So this is C answer is there. So in direct ELISA technique, what happens? We are basically, this is the basically antigen is there, which is basically the melamine or the whatever compound we want to detect from the sample, and antibodies will going to bind directly, and directly there will be some kind like fluorescence will be there or some kind of detection will be there. In indirect, antibody will be bound to some antigen, antigen will be bound to some antibodies, and that antibody will further be bound to another antibody that will going to detect produce the signal. And in capture antibody, this antibody, this antigen, this will going to basically bound with the captured with the help of some antibody, will further bound with some of the antibody, and that will the signal will be produced by different antibody, that is sandwiched, because antigen, it is basically sandwiched between two antibodies, the capture antibody and the detecting antibody. So next is the competitive ELISA. So here is basically the antigen which is bound with the antibody, but there are another inhibitory antigen will be there. So because of these two, for presence of these two antigen, there will be competition. So that is competitive ELISA. So here the ELISA technique is basically used to identify the melamine content in the milk. So basically next question is about electronic nose. So adulteration detection using an electronic nose is consuming and destructive. This is assertion. Reason is it relies on sensor arrays to analyze the chemical composition of food. Anyone who would like to answer this question? B and C, Aman and Jitnyasa. So is this question you are telling, or is this a previous one's answer? Okay, let's see. So here C answer is basically the tech detect the food adulteration. It can be conventional and it can be automated. So the conventional, it includes basically the electronic devices which use to identify the food adulterants, or the laboratory tests using the chemical substances, and the manual inspections and the observation based techniques or the methods. Now the automated methods are basically used, which can be vision based, or techniques which are based on the chemical composition. So vision based can include the machine learning and the deep learning models, like it includes ANN, it includes decision tree, random, these new techniques. And based on composition, it can use IoT based data collection technique, the quality control uh, of the food using electronic methods. Like this electronic methods, it includes basically e-nose and e-tongue. So e-nose we are discussing right now. So here the electronic nose, which is e-nose, is basically a rapid and non-destructive technique for detection of the physical and the chemical food adulterants and quality analysis by imitating the human senses. So it uses the senses array to sniff and to analyze the VOCs, which are volatile organic compounds in the food, making it highly efficient for real-time operations. So the e-nose technique is widely for its speed and ability to preserve sample integrity, which contradicts the assertion that it is time consuming and destructive. So this is obviously a sensor array technique which is correct and analyze the chemical composition of the food with organic compounds, but it is not time consuming and the non-destructive technique. So this is wrong. Assertion is wrong. So uh, it basically uses the sensor arrays, right, to analyze the chemical composition. So it analyzes basically the volatile organic compounds, or which are there in the air, not exactly the chemical compounds. So they both are incorrect, both are false here. So what its function, how electronic nose looks, or what its function is, the food sample will be there. So it will produce some volatile organic compounds, so the order compounds, not exactly the but the odor producing compound. So the sensor arrays will going to detect and recognize the pattern and try to identify it from the history or the past data, or that it will have some data. So from that it will going to identify or try to match which kind of odor is there. So in human nose, we have the olfactory receptors, and that will this food say, this odor will going to go in the olfactory receptors, then olfactory bulbs, then to the brain, and brain will going to identify. But here in electronic nose, the sensors will going to take this volatile organic compounds, and response will be generated, which will be analyzed with the past or the whatever database is there, and then output is generated. So here C, which is assertion and reason, both are false. Here is a more detailed diagram is given. So it is saying that odorant molecules are there. This is human nose. This is electronic nose. So the array sensors are taking these odorant molecules, and the sensors response are produced. The features extraction is there, and the pattern is recognized. And finally, we analyze which kind of food is there. Okay, let's see this question. So in column 1, we have toxins, and in column 2, their sources are given. We need to match. Anyone who would like to answer this question? So we have saxitoxin, prussinic acid, then we have aflatoxin, tetrodotoxin, and we have the sources aspergillus flavus, pufferfish, cherry pits, and mollusk and shellfish. Anju and Jignasa are saying C. Okay, so C is the correct answer. So we can have the toxins which are produced naturally from the plant, and we can have the toxins which are naturally produced from the animals. Then we have environmental and process contaminants, fungal toxins, mycotoxins, and bacterial toxins. These are the different classes of the toxins we can have. So the this toxin, basically they are basically the marine kind of, or they belong this category, animal origin toxin, or they generate from the marine source. Toxin is basically a pyro pyroluropyrin alkaloids. Basically, they are basically the neurotoxin, which means that they are affecting the nervous system. So neurotoxin which are produced by some kind of marine organisms, like this shellfish, which is dinoflagellates. So this kind of particular class of species uh, of the fish, shellfish, this is produced by this class. So mollusk and shellfish, like the clams, mussels, and oysters, they basically accumulate these toxins during harmful algal blooms, uh, when resulting in paralytic shellfish poisoning. So basically, they are generated from the marine sources, and if the minimal lethal dose is around 1 to 4 mg per kg, and as per WHO and EFSA, so we have the set limit, which is 100 gram of shellfish soft tissues can have has the maximum 80 microgram of this toxin. So the symptoms when we have the ingestion of this toxin, the nervous system is affected, nausea, vomiting, oral paresthesia, then visual disturbances can be there, muscle paralysis can be there, and myalgia can be there. So these symptoms they can appear within zero point 0.5 to 2 hours after ingestion, and in severe cases it can lead to respiratory paralysis and even death. So what happens is basically it is affecting this uh, in the nervous system. We have these axons. So basically so what happens in the normal situation, this there are this calcium and sodium channels are there, so they basically will propagate and impulse will be propagate like this in like they will be exchanged, and the impulse will be propagated. But when there is this toxin will be there, so what will going to happen, this will going to block this sodium and the calcium channels, so ions will not going to uh, transfer, and the nerve impulse or the signals will not going to be propagate. So thereby the there will be effect with the nervous system or the neural signals. Prussic acid, it is also known as hydrogen cyanide, is found in the seeds of certain fruits like cherries, apples, apricots, and peaches, and it is released when glycosides, like this is the glycosides. One example is amygdaline. So these are in their seeds, apricot seeds or the apple seeds. So these will going to be hydrolyzed, and then we can get this hydrogen cyanide. So this can undergo with the reaction with uh, like uh, beta glycosidase can act on amygdaline, and it will form this pyrinosine, and after that it will further be acted by beta glycosidase, and this compound can be produced mandilonitrile, and further the enzyme can be acted and hydrogen cyanide can be produced, which is toxic. So this cyanide poisoning from ingestion can lead to symptoms like dizziness, headache, or can in severe cases respiratory arrest. So this persenic acid, it inhibits basically the oxygen utilization by the animal at the cellular level, which results in the suffocation. So ruminants, which are more susceptible because ruminants microbes have this enzyme. So in animals, these enzymes are there, so they have these enzymes that release the persenic acid in the digestive tract, and that's why the death often can be there. And within even the few minutes of the exposure, can this the death can be there. If there is inhalation, there is there of so what happens with the concentration of around 100 to 200 ppm, so it can be fatal within 30 to 60 minutes, but if at higher concentration like 270 to 300 ppm, it can cause immediate death, so it is very harmful. Aflatoxins, they are basically like this. So they are carcinogenic toxins produced by the fungi, which is these are the mycotoxins. These aflatoxins are belongs to the category of mycotoxins, and this prussic acid is from plant origin. So these are mainly from this aflatoxin is produced from Aspergillus flavus and Aspergillus parasitaceus. So these toxins contaminate the food crops like peanuts, crops, and tree nuts, particularly under the warm condition and the humid condition. So basically, the aflatoxin B1 is basically ingested by the human. When it is ingested, then it can undergo oxidative stress and can produce this ROS, free radicals, uh, oxygen reactive oxygen species it can produce, and also it can produce uh, AFBOs. So those are aflatoxin B1 exo 8 9 epoxides. So it will finally going to uh, affect the proteins and the RDNA proteins and the RNA. So it will going to affect the, because it is affecting the DNA and the RNA, so it is affecting the genotoxicity. So it is the genotoxicity because it is interfering with the gene expression at the DNA integrity and the genomic stability, and it inhibits with the DNA repair also. Then it also basically uh, disrupts the cell integrity, disruption of cell vitamin functions. So it affects the like organs failures and the death. So it resulting the acute toxicity, and also it is hampering or dysregulating the innate and adaptive immunity. So it is interfering with the immune response also. So it is immunotoxic also. So aflatoxin is affecting the DNA. It is also affecting the normal tissues or the organ function, and also it is affecting the immune response function. So it is very toxic compound, and this tetrodotoxin tetrodotoxin, sorry, so is highly potent neurotoxin which is found in certain species like the fishes like puffer fish. So it blocks sodium channel in the nervous system. So basically this is there, this is the sodium channel. So it will going to bind with this sodium channel, and it will hamper this passing of the sodium ion. So it will affect the nervous cells. So muscle paralysis can be observed, respiratory failure can be observed, and death also can be there. So if mild symptoms includes basically headaches, sweating, muscle weakness, nausea, vomiting, abdominal pain, and diarrhea, whereas the severe symptoms can include paralysis or even death or limited mobility, and death due to respiratory failure. And its toxicity is around greater than 1250 times even than the sodium cyanide. So this saxitoxin is basically relevant to this shellfish, molluscan shellfish, and this prussic acid is basically found in cherry pits. Aflatoxin is basically found in the from the aspergillus flavus, and this tetrodotoxin is basically from the puffer fish. So till now, I hope the discussion is clear to everyone. If you have any doubt, you can feel free to ask. So I am discussing this next question on the anti-nutritional factor, which is lectins in legumes are considered anti-nutrition, and reason is lectins interfere with the protein digestion by inhibiting the digestive enzymes. So this is basically the lectin. Anju A, Aman A. They both are correct that lectins basically are naturally occurring proteins which are found in legumes such as the beans, lentils, and the peas. And these lectins, they are basically the glycoprotein, which means that they possess at least one carbohydrate recognition domain. So, which is CRD, one CRD is there at least. So, they will basically specifically and reversibly bind to the carbohydrate groups. So, they are basically binding to the carbohydrate groups. I'm so sorry. I think the answer B is correct here because the reason is incorrect. Lectin interfere with protein digestion by inhibiting digestive enzymes, but it is binding with the carbohydrates. So lectins, they are interfere with the carbohydrate digestion. Okay, so it interferes by binding to enzymes like trypsin and chymotrypsin, so which are essential for breaking down of the protein into the amino acids. So both A and B are basically lectins are from the legumes and they are anti-nutrition factors also. And they are a glycoprotein, so they basically bind with both the carbohydrates and the protein digestion, impair the protein digestion because they impair the bind with the trypsin on the chymotrypsin, which are there for the digestion process. So they'll bind, and that's why there is the inhibition of the digestive enzymes. So this inhibition basically disrupts the digestive process, leading to poor nutrition absorption and digestion. In addition, lectins can damage the intestinal lining, further reducing the efficiency of digestion and absorption. So the lectins adversely affect joint pains, migraines, acne, inflammation, and the agglutination of the RBC. So basically, this undigested lectins, they're going to bind to the gut and they also with the enzymes. They also make the amino acids non-available. The change in the organ and alters the metabolism, and they are mucotractive effect show, which means that they drains the energy also. So they overall affect the nutrition absorption. So impairs with the immunological function and also shows the poor growth. So overall, the, there can be death because of this lectins. So both assertion and the reason are correct, and the reason is the correct explanation here. Which of the following statement is incorrect with respect to anti-nutrients, which are lipase inhibitors, reduce the absorption of fats and lipids, deficiency of fat-soluble vitamins, amylase inhibitors impairs the growth, prevents protein digestion, oxalates, they prevent the calcium absorption and kidney stone formation, then phytates, they have the mineral deficiency, zinc, iron, calcium, magnesium. We need to tell which statement is incorrect here. Anju B, Aman A, Prithinga D. A 1, 2, and 4. Okay, let's see. 2 is the correct answer here. So amylase inhibitors, they grouped into phenols, saponins, alkoids, terpenes, glycosides and carotenoids and polysaccharides. They reduce biochemical functioning of the enzyme lipase, and that's why it causes deficiency of fat soluble vitamins, which are and they are also found in beans. So basically, lipase inhibitors, they reduce absorption of the fat and the lipids. That's why deficiency of fat soluble vitamin can be observed. Then amylase inhibitors, they are basically linked to the starch digestion. So amylase inhibitors, they target amylase enzymes, which are responsible for breaking down of the starch into sugars, thereby reducing the carbohydrate digestion. It impairs the activity of salivary and pancreatic enzymes or amylase, shows the positive effect on the glycemic index control in the diabetes. So it found in the seeds of the plant such as cereal grains like wheat, maize, rice, barley, as well as in the legumes like kidney beans, cowpea, and zucchini beans. Then they do not directly impair the growth or prevent protein digestion, but they will going to affect the amylase only, not the protein. So this one is incorrect because they affect the carbohydrate digestion, not the protein digestion. Whereas if we see previous one, these lectins, they will affect both the carbohydrate and the protein digestion. But here amylase, they will going to affect only the carbohydrate digestion, not the protein. So this is incorrect here. Then oxalates, they are basically the oxalic acids, which is this structure, oxalates. So oxalic acids forms potassium, sodium, iron, calcium, and magnesium salts or esters, which are called oxalates. These esters, when they form with the minerals, then oxalates make them the less available. So in wheat, rye, millet, and barley, they found in less amount. And phytates, they are around 50 to 85% of the total phosphorus in some plants. This is the phytates. So they chelate this calcium ion, zinc, all these micronutrients, they're going to chelate with this phosphorus group and inhibit many reactions of the digestive enzymes where these minerals act as a cofactor. So where these minerals are acting as a cofactors, it will bind from the chelate and it will not going to participate then. So they are found in cereals, pulses, nuts, and seeds. So here, lipase, obviously, they reduce the absorption of fats and lipids. Then oxalates prevents calcium absorption and kidney stone formation, and phytates mineral results in mineral deficiency because it forms the chelates. So only statement 2 is incorrect. Okay, next is about the food laws or food regulations. So in the under given statement, which statement is correct? So statement 1 is that set of standards and guidelines that govern the process of food production, distribution, sales, and consumption are known as food laws, and food regulation contains detailed provisions related to different categories of products defined separately in each set of regulations. Aman is saying B only 2, and Anju is saying 1 and 2. Muskan is also saying B. Okay, so C is correct. Both are correct here. So are basically the set of standards and guidelines that are going to govern the process of food production, distribution, sales, and consumption. And its objective is to protect the consumer's health and enhance the production rate. And food regulation means it contains detailed provisions, basically related to different categories of food products defined separately in each set of regulations. So it includes also minimum quality requirement to ensure that the food is unadulterated, safe, processed in proper hygienic conditions. So both statements are correct here. In column 1, we have the different regulatory bodies like FSSAI, JFECA, and then Codex, and then FAO. Their respective functions are given. So we need to match here. Like 1A is managing agriculture and food related programs. B is settling or setting international food standards. C is evaluating food additive safety for international use. And D is establishing science-based standards in India. Anyone who would like to match the regulatory bodies with their respective functions? Okay, let's see the answer. D is the correct answer here. This is FAO sign, this is FSSAI, and this one JECFA. So basically, the FSSAI is the apex India's apex regulatory authority for food safety and standard, and it is established under Food Safety and Standard Act FSSA 2006. So its primary role is to develop the science-based standard for food products and regulate the manufacture, distribution, sales, and import of the food to ensure availability of safe and wholesome food for the consumers or the for human consumption. So FSSAI is for the science-based standards in India. Then this JECFA is basically scientific based advisory body which is established by jointly by FAO and WHO to evaluate the safety of the food additives, contaminants, and residues of veterinarian drugs and pesticides. Its evaluation form the basis for the ADI, which is acceptable daily intake, and MRL levels, which is maximum residual levels used in international food standard and trade. JECFA, it serves as a independent scientific community which performs basically the risk assessments and provide advice to FAO, WHO, and other member country for both the organization. So it basically only food additives that have undergone this JECFA safety assessment are found not to present an appreciable health risk to consumer and can be used internationally for the trade. Then FAO is basically this. So this JECFA, it is for basically setting of the or it basically check or assess the risk for food additives for international use. Then FAO is a specialized agency of UN, United Nations, which leads international efforts to combat hunger and improve agriculture, forestry, and the fisheries. So this is especially for managing the agriculture and food related programs. Then Codex Alimentarius Commission is an international body jointly established by FAO and WHO, and it sets international food standards. The dual objective of this commission is to protect the health of the consumer and also to facilitate the international food trade. So it includes basically FAO and WHO, and then this Codex Alimentary Committee formed, and it has some executive committee, and then subsidiary bodies are there, Codex committees and coordinating committees. This Codex Alimentary and Alimentarius structure is that it includes standards and like specific standards for food and also the general standards for food additives, their labeling and packaging, and also method of analysis of the sample. And the code is it has some code of practices like code of hygiene practices like HACCP, and it has some guidelines and other recommendations. So it has some codex principle for setting the policy and guidelines for interpretation of the codex principles like labelings and claims. So this codex is basically for setting international food standards. So here answer D is correct. Now we have this next question. The blank outlines ADI values for food additives internationally. So this is very simple question. We just now discussed about it in brief. So Anju is saying C, this joint FAO for ADI limits for food additives internationally. Here the answer is Codex Alimentarius Commissions because it establishes the international food standards, including the ADI limits values for food additives to ensure consumer safety and promotes fair practices in the trade. So the codex provisions they concern about the hygienes and the nutrition quality of the food, including the microbial norms, food additives, pesticides, veterinary drug residues, contaminants, labeling and presentation, and methods of sampling and risk analysis. Codex Alimentarius is basically includes the standards for all the principal foods, whether it can be processed, semi-processed, raw, for distribution to the consumers. This committee has brought around 1,000 food additives along with their permitted levels. So it is with relation to the safety. These food additives have to comply with Codex Standard 192 1995. So it says that no appreciable health risk to consumers as shown when speaking of endorsed food additives. So it has to be considered that the use implies proposed use level. So it should be under acceptable daily intake. So second, endorsed food additives are always associated with an acceptable daily intake value or similar safety assessment. The probable daily intake has to be carefully considered when speaking of a special consumers group. Third, the intended technical effect for the use of endorsed chemicals determine the lowest level of these additives in the food, and also the food additives should be food grade quality standards. So the use of these additives is justified only when it provides clear benefit and has no health risk to consumers and do not mislead and fulfills one or more technological purpose which is defined by Codex. So here B answer is correct. Now the last question for today. The JECFA evaluates contaminants and natural toxins in the food. This is assertion, and reason is that it prepares scientific reviews for contaminants but excludes natural toxins. Anyone who would like to answer this question? Aman C. Reason is false, assertion is true. Anyone else who would like to answer? So he's correct that this JECFA evaluates both the contaminants and the natural toxins in the food as a part of its risk assessment role, but the reason is incorrect as it is claiming that natural toxins are excluded. So it is incorrect. So risk assessment and safety evaluation of the food additives is done by basically JECFA, and about processing aids, flavoring agents, contaminants, natural toxins, residues of veterinary drugs in animal products, etc. also, and it prepares a specification of the purity for food additives. So C is correct here. This is correct that this committee evaluates contaminants and natural toxin in the food and scientific reviews basically for contaminants and natural toxins. The topics we discussed today included chemical food additives, its definition, its classification, then uh, the different chemicals like the antioxidants and the chelating agents we discussed. We discussed about the nutrient supplements like vitamin D and non-nutritive sweeteners like aspartame. Then we discussed about functional food additives, like we discussed about flavor enhancers, we discussed about coloring agents, flour improvers, leavening agents like physical, chemical, then emulsifiers like lecithin. Then we discussed about the ripening agents, which included calcium carbide. We discussed about food adulterants, its definition, its types, the common adulterants, and how is their detrimental effects, and how we can detect from different methods like chromatographic or spectroscopic or ELISA, which is immunobased, and electrophoresis. And then we discussed about detection methods like melamine detection, also urea detection also we discussed. Then toxic and allergic compounds, we discussed about the different toxic compounds, toxins, and also we discussed about the anti-nutritional factors also. Then we discussed about the international regulation on food additives, about FSSAI, food laws, food regulations, and then we discussed about this committee, which is uh, the Codex Alimentarius Commission, FAO, and we discussed about this committee, which is JECFA. And in next class, we'll be discussing about traditional food preservation technologies, chemical and biopreservation of food, non-thermal technologies for food preservation, alternate thermal technologies of food preservation, and low temperature preservation of food. So thank you so much for joining today's class. Let's meet on next Sunday, 4 to 6. And if you have any doubt, please feel free to ask. Otherwise, This is the end of the session. You can leave the meeting. Thank you so much for joining today's session. Aman, thank you so much for joining my session. Hope to see you in the next session. So I am stopping the recording, and if you have any doubt, please feel free to ask. Otherwise, you can just leave the meeting, or you can ask your questions on Q&A or discussion forum also.